So, hello, good afternoon. Here today we want to look at this question. We are asked to resolve this into partial fraction. So, to be able to resolve this, so first, before we do that, there is a particular technique in partial fraction that we need to understand. That whenever any of these denominator is raised to power 2, 3, 4, or 5, whatever power it is raised to, then we will have to repeat this in such a way that for this one it is raised to power 1, it's going to be a, and it's a linear factor. It's going to be a 2x minus 3 now plus this is also a linear factor. It will have a constant which is b at the numerator x plus 1. Now because the root is repeated, we'll have to introduce another constant there, c into x plus 1 square. So the more the power, then the more the number of repetition that we are going to be having there. So for instance, if it is raised to power 3, then we need to add another one, another term, which will be d, and that will be raised to power 3. So the more the number of the power, then the more we raise that we repeat the roots. So it is called repeated roots in partial fraction. So once we have this, then we are going to look for A, B, and C. So as for this one, it is easy because we can use our normal formula to determine this one, which is by using this to multiply every term here. That is, use this to multiply this term, use this to multiply this term, to multiply this term. So to get A, is going to be A will be 7x plus 2 all over, when this one multiplies, this is going to cut this on the left there, and that will be x plus 1 square. So when x is equal to, you equate this to 0, and the value of x there will be substituted here. That will be 3 all over 2. Okay, so by the time we now substitute 3 all over 2 here, so this is going to be equal to 3 over 2 plus 1 square. Okay, so this is going to be 21 over 2. 21 over 2. And 2 times 2 is 4. Plus that 21, that's 25 over 2. While this one is 3 times 2. 2 times 1, 2. Plus 3, that's 5 over 2 square. That will be 25 over 4. Right? So if we do division, 25 over 2 times 4 over 25. We convert division to multiplication. We invert the fraction at the denominator. So 25 equal 25, 2 equal this. So we are left with 2. So the value of A is 2 from here. Then for B, to be able to get B, a simpler way to be able to express this is just to expand this. You expand this by using this to multiply everything. That is the denominator to multiply every term there. So and this is going to be 7x plus 2 to be equivalent to A into brackets. So when this cuts this, we are left with x plus 1 square here. Then B, when this cuts this, we are left with 2x minus 3 and x plus 1. One of it cuts this, right? And for the C, so when this cuts this, only this will be left. So C will be what? 2x minus 3. Okay? So with this equation obtained, we'll now expand this so that we'll be able to compare the terms. So that will be 7x plus 2 will be equivalent to A into expansion of this is square this, that will be x squared plus multiply the 2, x times 1, x times 2. So that will be 2x. Then 1 square is 1. Then B, multiply this with this, that will be 2x squared, right? 2x times 1, that will be 2x, and 2x and 2x times 1, that will be 2x. Then minus 3 times x, minus 3x. Minus 3 times 1, that will be minus 3, right? Then the third one, which is c, is 2x minus 3. Okay? Having expanded everything, then we'll now compare. So we'll compare the ones with x raised to the power 2. If you look at this, x squared, the coefficient of x squared here is 0. Yeah? So comparing the x squared on both sides of the identity, that will be what? 0 on the left hand side will be equal to a times x squared, which is ax squared, and b times 2x squared, that will be 2b. Then there is no x squared here, so let's call this one equation 1. We already know what a is, so it is easy for us to get b from here. So b from here is going to be minus a, right? All over 2. And that will be minus a is 2 all over 2, and that will be minus 1. So we now know b to be minus 1. So to get c, we can compare the constant term. Because it's simpler to get this, so we can use this constant term here and the constant term here, the constant term here, constant term here. So when we compare the constant term, that will be 2 will equal to a times 1, that will be a, then b times minus 3, that will be minus 3b, then c times minus 3, that will be minus 3c. So when this one is obtained, we can get c. What is c? Bring c to this side and bring the others to the other side. So c will become a minus 3b, right? Then minus 2 all over 3. So what is a? A is what? 2. And what is b? B is minus 1 minus 2 all over 3. Okay, 2, 3, minus 1, minus 3 times minus 1, that's plus 3, right? So 2 plus 3, that is 5, and 5 minus 2 is 3, right? And 3 over 3 is 1, right? So that will be 3 all over 3, which is 1. So we have gotten our c to be 1. So having obtained this, we have obtained a, b, and c. We now put them back into this expression, into the fraction that we want to resolve. So a is what? 2. So 2 will be here. And b is what? Minus 1. So this is going to be minus 1. Then c is 1. So this is the final answer to this. Thank you.